right, solving systems of equations. Let's go. Okay, so first question is, what is a system of equations? It's actually fairly simple. It's two equations. So if I had y equals 10x plus 5 and y equals 15x, that would be a system of equations. There's two of them. So substitution is substituting an equation for a common variable. So you take an entire equation. So in this case, I have y equals 15x and y equals this. I can substitute 15x for that y, and then that would give me a 15x equals 10x plus 50. And that would be a way to solve for x, and we'll get there. So that's just what I was saying. Substituting an entire equation for a common variable. So we kind of say the system can be the solution to the system of equations is an ordered pair of 10, 50. So what they did here is they first replaced x and y. Oh, they say they tell you what it is, and they substituted in for both. So that's how we know after they found it. This is kind of how to check your answer. Anyways, we'll keep going. Okay, so solutions to systems of equations. You have two options. You could have one solution, which is where they intersect if you graphed them. There's no solution, which means they have parallel lines. And there's infinite solutions where there's actually, you could say, two lines on top of each other. So if the line come out to be the exact same thing, then every solution is the same. So those are kind of the two special cases that you might see later on in our lesson. All right, so this one says, solve the system of equations by graphing. So in this case, we just graphed, they're both in y equals mx plus b. So we'd start at -2, and we'd have a graph of up 2 over 1, up 2 over 1, up 2 over 1 to get that one. And then y equals x minus 1. So we'd start at -1, and we'd go up 1, 1, up 1, 1, up 1, 1, up 1, 1. That's fantastic. They intersect at the same place, and we can tell exactly where it is. So 1, 0, it looks like on the graph that's where they are, but we probably should at least throw them into check the solutions here like we did right here, where we take the one that we saw on the graph and we try it in both. That's what we're going to do. So we check the first one. We substitute 1 and 0 in for x and y. We subtract them out, it comes out to 0, so that one works. Or that one comes out, and this one is also a solution for the other line. So I'd say that yes, that would be the answer, 1, 0. All right, solve this equation by graphing, go. All right, so these are in y equals mx plus b. So we're going to do this. They're going to go across at 3 and 4. So go 1, 2, 3, 4. They're both positive, so they're going to go up a little ways. So let's just go 1, 2, 3, 4, 5, 6. These are just rough ones. All right, so I start at +4, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. That's going to be one line. And then my second one goes to +3. It's going to go up 2 over 1, up 2 over 1, because it's 2 over 1. So that looks like a probable up 2 over 1, up 2 over 1. So it looks like that one's going to be at kind of that angle. So I'd say that'd be at 5, 1. So 1, 2, 3, 4, 5. Yeah, 5. So 1, 5. Sorry, I flipped those. X is 1, Y is 5. That's what it looks like to me. And the book agrees. I like it when we all agree. All right, so one CD club, it charges a member of $25 annual fee. After that, the CDs cost $5 each. Wow, a CD club. Whew. Been a long time since I've heard that one. Another CD club B has no annual fee and sells member CDs for $7.50 each. So basically, they're sending you a monthly CD. I know it's a long time since that's happened. How many CDs would you need to buy in a year for the club cost to be the same? So we know the annual fee and the cost per CD. So we need to write an equation to represent each club and then set them equal to each other and find the solution. So we're going to let X be the number of CDs and let Y be the total cost. So we keep everything straight. So the total cost, CD, cost of a CD, annual fee. One was $5, one was $7.50. So one is $5 a CD with a $25 annual fee. The next one's going to be a $7.50, and then no annual fee. Oh, they wanted us to just graph it. Even better. So graph the solutions. Looks like 10 CDs, 75 means that if 10 CDs are bought, then both would have the same cost. So they actually just graphing them is all we're doing. I love it. So check the solution by substituting 10 and 75 into both equations. After we do that, it'd come out as 10. So it does look like you really do need to, once you graph it, it looks like an approximate spot, especially because this one doesn't go right across an exact spot. It's coming in there close to figure out the correct one. All right, your turn, go. Oh, this is lovely. They gave us the two equations. Oh, which club would be better deal for a customer buying 12 CDs in a year? Oh, this wasn't your turn. We'll keep going. So for X, so we're going to make X equals 20, representing that Club A has a smaller Y value. So Club A would be a better deal, the one that ends up being lower over time. All right, your turn, go. All right, one film store charges an annual fee of $25 and then $5 per roll. The second one has an annual fee of $10 and then charges its customers $60. I think, how many rolls of film would you need to have processed for this cost to be the same? So so I'm gonna say per roll is X and annual fee is Y. So annual fee of Y and a customer of X. So I have 5X for this one and a film plus 25. And then 650X plus 10. And they would want me to graph this. So if I have, let's go 5, 10, 15, 20, 25. And we're going to have to do per month. Hopefully I get far enough here. So one starts at 25 and goes up $5 per. So this one's going to go right at the kind of 45-degree mark. And the second one starts at 10 and goes up a little faster. So it's going to crisscross out here. So here's what they came out with. They said about 10 is where they would have crisscrossed. And I know there's better ways to do this than graphing it, but that's all we're going to do for today. So we punch those into here. And as long as you were close, I'll probably count you good. So which will be a better deal? Well, probably the one that over time ends up being lower than the other one. So I'd say this one would be the correct answer. So annual fee of 25. So one film store. So I'd say the first film store is the better one. Oh, second. Second store offers an annual fee of $10 per roll. Oh, sorry, for developing 8 rolls. So at 8 rolls, crap. Sorry. So yeah, it would be the second store. All right, solving a system of equations by graphing. Now this one, when we look at it here, we can see that the slopes are the same. Got slope are both equal. So that means that they're going to be parallel lines. So that means there's no equation, or there's nothing, or no solution, there we go. No solution to the system of equations. All right, solve this system of equations. All right, so if we were going to graph this, let's see if it'll let me draw it here. So we'd have a -2, and then it's going to go up 3 over 1. That should be up 3 over 1. up 3 over 1, up 3 over 1, and then we'd have to start at 7, 1, 2, 3, 4, 5, 6, 7, sure, why not? Up 3 over 1, down 3 over 1. So even though I know I can look at this and say they have the same slope, therefore they're going to be parallel, I still need to graph it because it says solve it by graphing. So the answer would be no solution, and the graph should look like this. All right, solve this system of equations by graphing. Okay, so I have these two equations here, and I'd have to actually manipulate this one to get it into y equals mx plus b. And when I did that, they would end up being equal. So let's see if they do that. Both equations have the same graph. Any ordered pair on the graph that satisfies both equations will therefore be an infinite number of solutions. So same line equals infinite solutions. You try. All right, so I'm going to do this a little differently. I could do this one around and see what it comes out to be. But I'm going to try solving this a little bit differently when it comes to graphing. I'm going to graph it two different ways. So I'm going to go -3, and it's a slope of 2. So up 2 over 1, up 2 over 1, up, and I'm just kind of making this up here. So this one's going to go kind of like this. So if I made x equals 0, so 0 would be 3y minus equals -9. Divide both sides by 3 to give me y equals -3. And so then if I made this one 0, I have -6x equals -9. I divide both sides by 2/3, or sorry, it ends up by 6. Divide by -6. Actually, I'm just going to like this, -6, give me 1, and 1/3 would equal x. Well, that looks pretty close to x equaling 1 and 1/3. Y equals -3. So that even graphing it both ways gives me the same line. So there'd be an infinite number of solutions. Solve this by substitution. This is the one I was looking for earlier. All right, so since y must equal the same value in both equations, you can replace y with 2 in the first equation. So this one says y equals 2. I can just stick 2 right here and solve for x. So I take my first equation, I replace it with 2. I'm going to add 4 to both sides, divide by 3, and that gives me x equals 2. So my solution should be 2, 2. And you can check that solution by graphing. All right, your turn, go. All right, video's getting a little long here, so just going to do it quick. Substituting in 4, let's see, that's an x equals 1, -1, so I'm going to substitute -1 for that x, plus 1, -4, plus 1 would be -3, equals y, so it would be -1, -3. These are the numbers that I come up with. See you in class.